All right, let's get right into it. We're talking about a pretty huge breakthrough and how self-driving cars see the world. And, it really all boils down to teaching them one single crucial skill: how to predict the future.
So you'd think the answer is obvious, right? For a car to drive itself, the most important thing has got to be seeing what's around it. But what if I told you that just seeing, well, it's not even close to being enough? Yep, there it is. See, it's not just about spotting a car or a person or a bike. The real trick is knowing, almost for sure, where that car or that person is going to be a few seconds from now. And that right there, that's the core of what this is all about. It's something called state estimation. Okay, so take a look at this. This is the world from the car's point of view, just this wild, complex cloud of data points. And to get through that safely, the car's brain has to do way more than just draw a box around something. It has to figure out its speed and, even more important, its acceleration. Is it hitting the gas? Is it braking? Answering that question, well, that's the difference between a perfectly smooth ride and, a really bad day. So, for the longest time, the way we tried to solve this problem, it was just fundamentally broken. The whole system kind of had this split personality.
So you had these two different jobs, right? On one side, you've got data association. That's basically the what is that and where is it job. The system spots an object and then tries to keep tabs on it. Then, on the other side, you have state estimation. That's the crystal ball part. Where is it going and how fast? And for years, these two things were handled by totally separate systems that barely talk to each other.
It's kind of like trying to learn baseball from two different coaches who hate each other. You've got one coach only teaches you to see the ball. That's it. Just, yep, there's the ball. Then a completely different coach comes in and tries to teach you how to swing the bat, but they've got no idea what the first coach told you. It just doesn't work, right? It's super inefficient, and the two skills never actually help each other out. And that's the whole problem in a nutshell. These older methods, a lot of them based on things like the Kalman filter, they were totally siloed. The part of the brain that was predicting the future couldn't learn from what the car was actually seeing, and the part that was seeing things wasn't being trained to think about what might happen next. They were okay at their one little job, but they can never put together the full picture of what was really happening on the road.
Okay, so this is where things get really cool. Researchers basically said enough of this split personality nonsense. They developed a new model to give the system one single unified mind, and they call it STT.
And this quote from the research paper just nails it. STT, that stands for Stateful Tracking with Transformers. It's built from the ground up to do both jobs at the exact same time. It tracks an object, and it predicts where that object is going, all in one go. So how does this magic work? Well, think back to our baseball coach. Instead of two separate coaches, STT is like one single superstar coach who does it all. First, it takes in everything it can see about an object. Not just where it is, but what it looks like, how it's moving. Then it weaves all that information together over time, creating this deep memory of that object. Then a super powerful transformer model takes that memory and compares it to new stuff it sees to find the perfect match. And the final step? It uses that rich memory to make an incredibly accurate prediction of where that thing is headed next. The secret sauce, the real magic here, is this idea called joint optimization. The model isn't learning to see first and then learning to predict. Nope, it's learning both skills at the exact same time. And this is the beautiful part. Getting better at predicting where a car is going actually helps it find that same car in the next moment. And getting better at finding the car gives it more data to make an even better prediction. Each skill literally makes the other one stronger. It's a perfect feedback loop. But here's a fascinating twist in the story. Just building a smarter AI, well, it wasn't enough. The researchers quickly realized that the old way of keeping score, the old report card, it just couldn't show how much of a game changer their new model really was. See, for years, the gold standard for measuring this stuff was called MOTA. And you can pretty much think of it as a test with only one question. Did the little box you drew around the red car stay on the red car? That's it. It was all about association, just making sure the label stuck to the object. And right there, that's the huge critical flaw. Because what if the box is in the perfect spot, but the AI thinks the car is standing still when it's actually slamming on the accelerator? According to that old MOTA scorecard, you'd get an A+. The box is on the car. But in the real world, that is a total catastrophic failure. Your self-driving car would have absolutely no idea what's about to happen. So the team had to invent a whole new scorecard. They called it S-MOTA, or Stateful MOTA. Now, to get a point, it's not good enough to just put the box in the right place. You also have to nail the prediction of its state, its speed, its acceleration. This new scorecard measures what actually matters for keeping people safe.
All right, so with a brand new model and a brand new way to grade it, it was finally time for the main event, putting STT head-to-head against the competition. Now, if you look at the old MOTPS scorecard, STT does great. It comes out on top with a 58.2. It beats all the other top methods, including that classic Kalman filter. It's a solid win for sure, but it doesn't exactly look like a revolution, does it?
But remember, that scorecard is only telling us half the story. Because as soon as we switch to the new scorecard, S-MOTA, the one that measures what really matters for safety, well, the whole picture changes. And it changes dramatically. And boom! Just look at this. This shows the difference perfectly. That Kalman filter, which looked pretty decent on the old test, it only scores a 34.6 on this one. But STT, it scores a 48. That's not just a little bit better, that is a massive, massive leap forward. We're talking about a 13.4-point jump. That is a huge gap. And that single number right there, that shows you the incredible power of that joint optimization we talked about. STT isn't just a little better at finding things, it is profoundly better at understanding what those things are about to do. And that is the key to making these systems truly safe and reliable.
Okay, so let's zoom out a bit and wrap this up. What does this all mean? Why does this really matter in the grand scheme of things?
So here are the big takeaways. First, predicting where something's going is every bit as critical as just seeing it. Second, when you teach an AI to do both at once, like STT, it gets way better at everything. Third, if we want to build better AI, we have to get better at grading it, which is why we need things like S-MOTA. And what does all this add up to? It means we're on the path to safer, more reliable, and just plain smoother self-driving cars.
And the researchers themselves put it perfectly. This isn't just about their one cool model. This is about setting a whole new standard, creating new tools that are going to help push the entire field forward.
Which kind of leaves us with one last big question to chew on. If AI can get this good at predicting the chaotic, split-second movements of traffic, what else could it learn to predict? You start to wonder about other really complex systems in our world, right? Like financial markets or even weather patterns. What could AI learn to anticipate next?